Welcome to the deep dive. Today we're tackling something really fundamental to how our digital world actually clicks together.
Hmm.
How your devices automatically get their addresses on a network. We're diving into DHCP, the Dynamic Host Configuration Protocol.
Yeah, and specifically, we're looking at this key process inside DHCP called DORA. It's a four-step thing that gets your devices online, usually without you lifting a finger.
Right.
So our goal today, our mission, if you like, is to unpack DORA, discover, offer, request, acknowledge, and, really get how the devices and servers talk during this.
Exactly. Think of it like the secret handshake your phone does to get on the Wi-Fi. And understanding this is, well, it's super useful if you're learning about networks. Gives you real insight.
Absolutely.
Okay, so let's maybe start with the overview. DORA, it's a four-stage process.
That's right. It's the sequence a device, the client, uses to get its network setup details, mostly the IP address from a DHCP server.
And those four stages again.
Discover, offer, request, and acknowledge. That exchange makes it all automatic.
Okay, let's start at square one. Discover. What actually happens when, say, my laptop boots up and needs an IP?
So the device wakes up, joins the network, realizes, hey, I don't have an IP address. It needs to find a DHCP server.
Right.
So its first move is to shout out, basically. It sends a DHCP discover message.
Shouts out. How does it do that if it doesn't know where the server is?
That's the clever bit.
Ah.
It uses a broadcast. Think of it like yelling in a crowded room, hoping the right person hears you.
Okay, like an announcement to everyone listening.
Exactly. So at the network layer, because the client has no IP, its source address is 0.0.0.0.
Zeros. Makes sense?
And the destination is 255.255.255.255. That's the broadcast address for the network.
Gotcha.
Then down at the data link layer, the source MAC address is the client's own unique hardware address, the one burned into the network card.
Mm-hmm.
And the destination MAC address, also a broadcast. All Fs. F, 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 F.
So truly sending it everywhere on the local network.
Pretty much. Every device on that specific network segment will see that discover message pop up.
Okay, so the call goes out. Who answers? This must be the offer part, right?
Precisely. Any DHCP server on that network that hears the discover can reply. And it replies with a DHCP offer message.
And what's in that offer?
Well, it's basically the server saying, hey, I heard you. How about you use this IP address? It includes the proposed IP, maybe some other details like the gateway address, DNS servers, and importantly, the lease duration.
Lease duration, like how long it can keep the IP.
Exactly. It's not usually permanent. The server says you can use this address for, say, 24 hours or whatever the configured time is.
Okay, no, wait. If the client still doesn't have an IP, how does the server send this offer back just to that specific client? It heard a broadcast.
Good question. This is where it gets a bit nuanced between the network and data link layers. The offer message at the network layer often still uses the broadcast IP address, 255.255.255.255 as the destination.
Still broadcast. Why?
Well, the client technically still doesn't have an IP configuration. But crucially, the server does know the client's MAC address. It got that from the initial discover message.
Oh, okay.
So at the data link layer, the server sends the offer directly to the client's specific MAC address. It's a unicast frame at layer 2. The source IP is the server's IP, source MC is the server's MA, destination MA is the client's MA.
So network layer is broadcast, but data link layer is direct delivery using the MAC address. Interesting.
Yeah, it ensures the specific client gets the message efficiently, while maybe also letting other network devices or monitoring tools listening to broadcasts see the offer activity.
Okay, that makes sense. The client gets the offer, maybe even multiple offers if there's more than one server.
That can happen, yes.
So what does it do then? Pick one.
Usually, yeah. It'll typically pick the first valid offer it receives and then move to the next step.
Yeah.
Setting a DHCP request message.
Request. Okay, so it's formally asking for the IP it was just offered.
Exactly. It's saying, okay, server at this IP address, I'd like to formally accept the IP address you offered me.
Now, surely this message is sent directly just to that one server, right? It knows who it's talking to now.
You'd think so, wouldn't you? But no. The DHCP request is also sent as a broadcast?
Still a broadcast. Why? That seems inefficient.
It does seem counterintuitive at first glance. The source IP is still 0.0.0 because the client hasn't officially got the IP yet. The destination IP is 255.255.255.255.
Okay.
But inside that request message, the client includes an option that identifies the specific server whose offer it's accepting. so the intended server knows it's the chosen one.
So why broadcast it to everyone else then? What's the logic there?
This is actually quite important, especially if multiple DHCP servers sent offers.
Right, the scenario we just mentioned.
Exactly. By broadcasting the request, the client effectively tells all the DHCP servers on the network, hey everyone, I've chosen the offer from this specific server.
So the servers that didn't get chosen see that.
Precisely. They see the broadcast request, realize their offer wasn't picked, and they can then immediately return the IP address they had offered back into their available pool for someone else.
That's clever. So it prevents those IPs from being held unnecessarily. It's like a public announcement of acceptance.
That's a great way to put it. It's efficient network management, keeps the IP address pools accurate.
Okay, that makes total sense now. So the chosen server gets the request. It knows its offer was accepted. What's the grand finale?
The final step is the DHCP acknowledge message, usually called DHCP ACK.
The ACK, right.
This is the server officially saying, okay, confirmed. That IP address is now yours, along with these other configuration details.
And what details are usually in the ACK? The IP, obviously.
Yes, the assigned IP address is the star, but also, crucially, the subnet mask.
Subnet mask, right. That tells the device what network it's on.
Exactly. It defines the network portion and the host portion of the IP address. Without it, the device doesn't know how to talk to other devices, whether they're local or remote. The ACK will also reconfirm the lease time, default gateway, DNS servers, things like that.
And how is this ACK sent back to broadcast again?
Similar to the offer, it's generally broadcast at the network layer destination, 255.255.255.255,
Okay.
but unicast at the data link layer. So source IP is the server's IP, source MSC is the server's MS, but the destination MA is the client's specific MSC address. Direct delivery again at layer 2.
Got it. So let's just quickly recap the broadcast unicast thing because it's a bit twisty.
Sure.
Discover, broadcast on both layer 3 IP and layer 2, total shout out.
Correct. Client knows nothing yet.
Offer, layer 3 destination is broadcast, but layer 2 is unicast to the client's MAs.
Yep. Server knows the client's hardware address now.
Request, layer 3 destination is broadcast again, mainly to inform other servers. Layer 2 destination is, actually, I think I missed that one, is request layer 2 broadcast or unicast?
Good catch. The DHCP request is typically broadcast at both layer 2, FFF, and layer 3, 255.255.255.255. This ensures all servers definitely see it.
Okay, so discover and request are full broadcasts. Offer and acknowledge are layer 3 broadcast, but layer 2 unicast.
You've got it. That nails the typical flow.
Phew. Okay, so after that ACK arrives, the DRG process is complete.
That's it. The client now has its IP address, its subnet mask, gateway, lease time, everything it needs to get on the network and start communicating.
And the big takeaway here is what? Why do we care about these 4 steps?
Well, the main thing is automation. This whole DORA dance means you can plug in a device or connect to Wi-Fi, and it just works. You don't have to manually type in IP addresses, subnet mask. Imagine doing that for every phone, laptop, smart light bulb.
Oh, God, no. That would be a nightmare, especially in big networks.
Exactly. I mean, back in the day, we did sometimes have to do static assignments. It was tedious and so easy to make a mistake, cause IP conflicts. DORA makes network setup and management vastly simpler, scalable, and much less error-prone.
It's one of those foundational background things that just makes modern networking possible, really.
Totally.
Yeah.
It underpins so much of what we do online every single day, happening constantly without us even noticing.
So discover, offer, request, acknowledge. That's the handshake.
That's the handshake. Gets your device its ticket to the network conversation.
And it's running all the time, everywhere. It's kind of mind-boggling when you stop to think about it.
It really is. So maybe a final thought for you listening. Just consider, right now, how many devices you own are connected. Your phone, maybe a tablet, laptop, smartwatch, TV.
Yeah, tons.
Each one probably went through that DORA process, maybe even multiple times today, if they reconnected or renewed their lease. It's this constant, silent chatter that keeps our connected world humming along. Makes you appreciate the elegance of it, doesn't it?